Hi everyone. So today I will be discussing the June 2020 Mechanics Paper 2. Starting with question number 1. A particle of mass 2 kg is moving with velocity 5y plus 3j meters per second when it receives an impulse I Newton such that I equals AI plus bj. Okay, so that's the impulse that you are receiving. So they say immediately after the impulse, the particle is moving with velocity lambda I plus j meters per second, where lambda is a constant. Given that the magnitude, okay, so the magnitude of I is root 40. Find the two possible impulses. Okay, so you need to find the two possible values probably for the lambda value here, right? No, yeah. Okay, so let's try this. What's the equation we use here? We use I equals mv minus mu. Okay, so this is the equation we use, and you can see here that they have told you the initial velocity, the velocity before receiving the impulse. So initial velocity is the 5y plus 3j. The initial velocity is 5y plus 3j, and then they say this is the impulse. Immediately after receiving the impulse, the particle is moving with velocity. This is the final velocity. The velocity after receiving the impulse. So what I'll do is I'll use it into this equation. So impulse is given as AI plus bj. So we'll use here impulse AI. I'll use it as a column vector. Is that okay? So I will be using the impulse equation in vector form. So AI bj equals mass is 2 kg. Final velocity is lambda I lambda j. So basically it's lambda I lambda j minus mass is 2. Initial velocity is 5y plus 3j. So it's both 5, 3. Okay. So when it's given in terms of ij, you don't have to put any extra negative signs or anything because it's already considered. So you just have to apply the values over here. Okay. So final velocity is lambda I lambda j. Coefficients are lambda and lambda. The initial velocity is 5 by 3j. So 5 is the x component, 3 is the y component. Now let me add them together. So I get here 2 lambda minus 2 times 5 is 10. And this one I get 2 lambda minus 2 times 3 is 6. So this is the impulse. Okay, so let me keep this as I for the moment, impulse. Okay, so this is the impulse. Now they tell you here the magnitude of impulse is root 40. So how do we normally get the magnitude of the vector? So you can see your impulse is given in terms of I and j. So 2 lambda minus 10 I plus 2 lambda minus 10 j Newton seconds. This is the impulse in vector form. So when you take the square it, okay, when you take the sum of the squares and root it, you can get the magnitude. So the magnitude is given to you as root 40. Okay, so to get the magnitude, what we'll do here is 2 lambda minus 10, we'll square it, and 2 lambda minus 6 is squared, and then I take the square root. So this gives me the magnitude of the impulse, which is 40, root 40. Okay, so then we can remove the large root from both sides by squaring it. So I end up getting here 2 lambda minus 10 square plus 2 lambda minus 6 square equals root 40. When you square it, it's 40. Okay, so let's open the bracket. 2 lambda minus 10 square, where I'll immediately expand. This is 4 lambda square. 2 lambda into 10 is that's 20 lambda times 2 minus 40 lambda plus 100. And then when you open 2 lambda minus 6, so it's going to be 4 lambda square. 2 times 6, 12. 12 times 2 minus 24 lambda plus 36 equals to 40. Okay. Okay, so now let's input the values of lambda here. So I get 4, let's take the summation. So 4 lambda square plus 4 lambda square, I get 8 lambda square. Next, add the next pair of like terms, which is minus 40 lambda minus 24 lambda, which is minus 64 lambda. And then let's add the constants. We have plus 100 plus 36, and I'll bring the 40 over in this side. Okay, so 100 plus 36, when you subtract 40, so that's 100 minus, so that's 96. Is that okay? 8 lambda square minus 64 lambda plus 96 equals 0. So this is a quadratic equation with lambda. So let's simplify. I think the entire equation we can divide by 8. So let's divide the entire equation by 8. So when we divide everyone by 8, I get here lambda square. 64 divided by 8 is 8 lambda. So 96 when you divide by 8, we get plus 12 equals 0. So let's factorize. So when we factorize lambda square minus 8 lambda plus 12, we get lambda minus 2 and we get lambda minus 6. Yeah. So then the answers are lambda minus 2 equals 0 or lambda minus 6 equals 0, which gives me lambda equals 2 or lambda equals 6. So I got the two values of lambda. However, the question says us to find the two possible impulses. How do I get two possible impulses? Now, when I get two possible values for lambda, all I have to do is substitute those two lambda values into the impulse equation because the impulse is given as AI plus Vj, right? So find the two possible impulses, substitute the lambda value into this equation and get the two respective impulses. So when lambda equals 2, so when lambda equals 2, impulse equals, the substitute 2 lambda, 2 times 2 minus 10, 2 times 2 minus 6. Which gives me 2 times 2, 4. 4 minus 10, that gives me minus 6. 2 times 2, 4. 4 minus 6 is minus 2. So this one possible impulse value is minus 6i minus 2j. And the next one, when lambda equals to 6. So the impulse, 2 lambda minus 10. Substitute this impulse equation. Okay. So 2 times 6 minus 10, the other one. 2 times 6 minus 6. 2 times 6 is 12. 12 minus 10 is 2. 2 times 6, 12. 12 minus 6 is 6. So I get the other value of impulse is 2y plus 6j. So these are the two possible impulses. Okay, so these are your two possible impulses and the answer to our question. Okay, so now we will move on to question number 2. A truck of weight 9,000 newtons is traveling up a hill on a straight road that is inclined at an angle theta to the horizontal, where sine theta is 1/15. Sine theta is 1/15. So you have a truck that is moving up, right? They say the truck of weight 9,000 is moving up. Okay, and they say the weight is 9,000 newtons. So you can mark the weight. 9,000 newtons. And they say when the truck travels up the hill with the engine working at 3p watts. So basically they have given you the power. Basically, so then for the engine, for the truck to travel up the hill, you know, it produces a what force? There must be a driving force produced up along the hill, right? So that's the reason why this is moving forward. So there's a driving force. Basically, the equation we use connecting power and the driving force is what? The equation is power equals driving force into velocity, right? Yeah, there's the equation. Power equals driving force into velocity. So then they say here the power is 3p, right? They say the engine is working at 3p watts. The truck is moving at a constant speed of 12. Okay, they have told you it's moving at a constant speed. So constant speed means forces are balanced, right? Because there's no acceleration. Okay, so then shall we mark all the forces here and then later on, so this is another story. The truck travels down the hill. Okay, before I go to down the hill part, let's draw the, let's mark all the forces for the truck traveling up the hill. So I have the driving force produced by the engine. I have the 9,000 Newton, which is the weight. What else do I have? They have said, I think the resistance to motion of the truck from non-gravitational forces is a constant force of magnitude R. So we have the resistive force R. So resistive force is against the direction that you are moving. You are moving up, resistive force is down. What else? You said normal reaction. Yes, normal reaction is acting perpendicular to the surface. What else? Now, normally when I have a question like this, when we have a an object that is moving along the inclined plane, we tend to keep, I want to keep my forces in the directions along the plane and perpendicular to the plane. So you can see this 9,000 Newton is directly vertical. Shall we resolve it? So what happens when you resolve? Yeah, the theta comes here, right? Then you get here 9,000 cos theta. This side you get 9,000 sine theta. Sine theta. Okay, is this okay? Okay, so then shall we apply the forces here? So basically, first I'll use power equal driving force into velocity. So what's the power? The power was given as 3p, right? Driving force D is unknown. Velocity is 12, right? Okay, velocity is 12. Okay, so then we can get here D equals 3p over 12. Are you okay with that? The driving force in this case, we'll say the driving force is equal to 3p over 12. Now, since your object, since the truck is moving at constant velocity, what can you say about the forces acting along the plane? The forces acting along the plane are what? They are equal, they are balanced. So then can you make the balance the equation? The driving force must be equal to what? The driving force must be equal to what? 9,000 sine theta, which is acting downwards, and the resistive force. Because both of them are acting downwards and they both must be equal to the driving force. In order for this to be in, for the forces must be balanced in order for the truck to go with a constant velocity. Okay, so then I have another equation here, D equal 9,000 sine theta plus R. Shall we replace sine theta? 9,000 sine theta is 1 over 15 plus R. How much is 9,000 into 1 over 15? Driving force is 3p over 12. 9,000 into 1 over 15 is 600 plus R. Okay, I replace the driving force as 3p over 12 here. Shall we bring the 12 to the other side? Oh no, we can cut the 3 and 12, right? Yeah, we'll cut it. 3 times 1, 3 times 4. That it's better that you cut it. Now take the 4 to the other side. P equals 4 multiplied by 600 is 2,400 and 4 multiplied by R is 4R. Are you with me? So this is the first equation. This is the first equation we build when the truck is moving up along the hill. Okay, so then now we have to do the same thing for the later on. They say the truck travels down the hill along the same road with the engine working at P work. So now the engine is working at a different rate of the working rate is different now. At the instant when the speed of the truck is 12, the acceleration of the truck is G over 20. Okay, so now in this case, the truck is traveling down now. In the second scene, the truck is traveling down. And what's happening? The weight doesn't change. So obviously it's the same truck. So it's 9,000 Newton. You have a normal reaction. And what else is there? So normal reaction, actually I should use a different letter, right? Because we used R for resistive force. I should use a different letter for normal reaction. Let me use it as N. Are you okay with it? Don't use the same letter. Okay, I have used the same letter here, R and R. R is standing for resistive force. Okay, so normal reaction, I'll use it as N. What else do we have? There is a, they say the truck is traveling downhill and there is the engine is working at P watt, which means what? We have a watt force here. There is a engine force. So there is an engine force. So this time for the engine force, do you think it's the same as the engine force when the truck was traveling up the hill? No. So then we'll use a different letter here, D1 or some D dash something. DX, just use some letter. Okay, a little bit different than the earlier one. What else is there? The truck is traveling down the hill. Therefore, this time your resistive force is acting up. So they say it's the constant resistive force, the constant force of magnitude R is acting as a resistance. So basically, regardless whether you go up or down, the constant resistive force is acting. Okay, so this is what we have for force diagram. Now what do we need to do? And they say this time the particle is accelerating, right? It's accelerating at G over 20 meters per second square. Are you with me? And they have to given the velocity at the instant. So they have given at the instant when the speed of the truck is 12, the acceleration of the truck is G over 20. So at the instant when the speed is 12 meters per second, the acceleration is G over 20. They're again asking you to find the, they're asking you to combine what we got in the earlier part and over here and find the value of P and R. Roman numbers are there. Basically, it means you're trying to solve a pair of simultaneous equations. That's why when you see Roman numbers, it's basically a pair of simultaneous equations. Okay, let's do the same thing here again. So again, we'll use power equals driving force into velocity. So here D1 into velocity. Power is P, right? The power is P watts now. So input P watts, driving force is D1 and velocity is 12. Do you agree with me? So driving force is P over 12. Do you agree? So now in the next part of the question, am I going to make forces balanced now? For the next part, you saw in the earlier question, I made the upward forces equal to the downward forces because the object was traveling at a constant velocity. But now they say it's accelerating. Also, plus I need to first resolve the weight. Shall we resolve? What happens when you resolve the weight? I get this side 9,000 cos theta. The other side I get what? 9,000 sin theta. Are you with me? 9,000 cos theta, 9,000 sin theta. So then basically this time when we apply F equals, I can't make forces are equal. Obviously the forces are not in balance because the particle is accelerating. So then what do we do now? In this case, we must use F equals MA down. So what are the forces acting down? 9,000 sin theta plus D1 minus resistive force, isn't it? These two are acting down. This is minus R is equal to what? Is equal to MA. Mass is how much? So mass of the truck is, now they have given you the weight as 9,000 newtons, right? So if the weight is 9,000 newtons, what do we put for the mass? Yeah, so weight is mg, right? Which means the m value is w over g. Okay, so basically here your mass is 9,000 divided by the g value, 9.8. Okay, and into acceleration is g over 20. G over 20. I'll put here 9,000 over G. Shall I use instead of 9.8, 9,000 over G? I think we can see here G and G will cancel out, right? Then, so now I'm getting another equation. Shall we replace the D1 also? 9,000 sin theta is 1 over 20, right? 1 over 15. Plus D1 is P over 12. Minus R equal 9,000 over 20 is how much? Can you all simplify? 450. 9,000 divided by 15 is 600 plus P over 12 minus R equal 450. Okay, so then simplify, keep on simplifying, make another equation. Okay, so then P over, I'll take the, I'll multiply the whole thing with 12. Or else, okay, we'll keep it like this, right? I think it's easy for me to substitute. I'll just make R the subject. That's a lot easier. 600 minus 450 plus P over 12 equals to R. What am I supposed to find first? R or P? They want me to find the value of P first, right? In Roman number 1. So what I did in this equation is I took R to the other side, took 450 here. 600 minus 450 is 150. 150 plus P over 12 equals to R. So this is the second equation. Let's substitute that over to the first one. P equals 2,400 plus 4R. So replace the R value. R is 150 plus P over 12. Open the bracket, 2,400. 4 times 150 is how much? 4 times 150, multiply. 600 plus 4 times P over 12. The 4 and 12 will cancel out, right? 4 into 1 over 12, basically 1 over 3, right? Yeah, and then now take all the P terms to one side. P minus P over 3 equal 2,400 plus 600 is 3,000, right? P minus P over 3 is 3P, right? So you multiply here both up and down by 3. So 3P minus 1P is 2P over 3, right? Which gives me how much for P? 3,000 times 3 divided by 2. How much is it? 3,000 into 3 is 9,000. Divided by 2 is 4,500. So P is 4,500. Answer for Roman number 1. Then Roman number 2, they want you to find R. Replace P as 4,500, 150 plus P over 12. So P 4,500 over 12 because I replaced the P here with 4,500. Can I know how much is the R value? When you type in the cal, how much is the R value? 525. You can leave your answer in 2SF or 3SF is better. So R is 525 newtons. P is the P was the value in watts, right? The value of P watts. Yeah. Okay, so P is in watts. So 4,500 watts. Are you okay with the answer? I hope this is clear with everyone. Okay, question number 3. They say a uniform rod AB of mass 25 kilogram and length 3 meter has end A resting on a rough horizontal ground. The end B rests against a rough vertical wall. Basically, both ends are rough now. Okay, the coefficient of friction between the rod and the ground is 4 over 5. So mu value between the rod and the ground is 4 over 5 and the mu value between the rod and the wall is 3 over 5. They say here the rod rests in limiting equilibrium. What do you mean by limiting equilibrium? Limiting equilibrium is we have the object is the particular this uniform rod. This rod is about to slip. It's about to move. That's why it's in limiting equilibrium. In limiting equilibrium, you have the F max, the maximum friction. The maximum friction means what friction? The maximum friction is calculated by using mu r, right? You know about the equation F max is equal to mu r. So the maximum friction is calculated by mu r. So since it's in limiting equilibrium, you have the maximum mu r friction acting at both ends. They said the rod is at an angle theta to the ground as shown in figure 1. Find the exact value of tan theta. Let's find the exact value of tan theta. Okay. Shall we mark all the forces here? First of all, so what's the first force we have? The first one is at the ground. We have the normal reaction A. And also what do we have? Since it's a rough ground, we also have friction at the ground because the rod is about to slip down. Friction acts in the opposing direction. Do you agree with me? The rod is about to slip down this way. So therefore, the friction acts in the opposite way. Trying to, opposing the movement that we are trying to do. And at the wall, what happens? How does the normal reaction come? The normal reaction is perpendicular to the surface that you are touching. Now the wall is perpendicular. So therefore, normal reaction should be perpendicular to the wall. Are you with me? Normal reaction B should come like this. Do not draw this in any other direction. Like if you draw it in some direction like this or like this, normal reaction, that's completely wrong. Okay. So you need to make sure your normal reaction is marked perpendicular to the wall. Normal reaction B. And then what do we have? This object is about to slip down, right? That you can see the rod is trying to slip down. Therefore, friction will act which way? To oppose that, friction will act up. Friction acts upwards. I put FB. Friction at B. Okay, so actually these frictions, we can actually find the FA and FB values, right? Friction at A is mu R. Friction at A is mu times RA. So mu value at the ground is 4 over 5. Normal reaction A, are you with me? Friction A can be written as 4 over 5 into normal reaction A. Friction at B can be written as mu times normal reaction at B. Mu times mu at the wall is 3 over 5 into normal reaction B. Are you with me? Okay. Okay, so then I have those values. Shall we use those values here? FB is 3 over 5 times normal reaction B. FA is 4 over 5 times normal reaction A. Okay. And then what else are they saying? The uniform rod means the weight acts at the center of mass 25 kilograms. So weight is 25 G. And length 3 meter. Length 3 meter means it's a uniform rod. Each side has 1.5 meter, 1.5 meter. Okay, so then they are saying that, okay, so all the information is marked now. The rod is at an angle theta to the ground as shown in figure 1. Find the exact value of tan theta. Okay, so how do we find the value of tan theta? There are only 3 things to do here. You can make, you can resolve horizontally, the horizontal equilibrium. You can resolve vertically for vertical equilibrium. And you can consider moments about a single point. That's it. Doing all those three things should give you the answer. Okay. So shall we try to get the answer? Okay, so let me apply let's apply horizontal equilibrium. So when I try the horizontal equilibrium, what do I get? So horizontal equilibrium gives me what? Normal reaction B is acting to the left and friction A is acting to the right. Do you agree with me? Normal reaction B is the only force acting to the left and friction A is the only one acting to the right. So those two are equal to each other. Okay, so normal reaction at B, friction at A is written as 4/5 times normal reaction A. Are you okay with that? Then we'll also do vertical equilibrium. We will also perform vertical equilibrium. Up equals down. Friction, the force B, the friction B is upwards plus the normal reaction A is also upwards. Is what? Is equal to what? Friction at B is upwards, normal reaction at A is upwards. Who else is there? Is equal to 25G. Are there any forces that I need to specifically resolve here? Do I have any force who is perpendicular or parallel to the plane that needs to be resolved? No, I think you can see every single force here is either horizontal or either vertical. Then we can work with those two directions here. The horizontal is the x direction and the vertical y direction. We don't need to resolve anyone because everyone is in the perfect direction. Friction at B is 3/5 times RB plus RA equals 25G. Okay, so shall I replace the RB value here? We can replace the RB value here, right? 4/5 times RA. 3/5 times normal reaction B is 4/5 RA plus RA equals 25G. So what do we get here? 4 times 3, 12/25 normal reaction A plus normal reaction A is equal to 25G. How much is 12/25 plus 1? 12/25 RA plus 1 RA. Can you add everything? How much is it? How much? 37/25 RA equals 25G. So normal reaction A is 25G times 25/37. How much is it? 25 times 25 is 600. We leave the answer in terms of G at this point, that we are not doing any, we are not taking any, we are not losing any significance. So how much is it? 25 and 25 is 625G/37. Are you all okay with that? Did you come up to this point? Okay, so now substitute the normal reaction A value and get the RB. Normal reaction B is 4/5 times normal reaction A, which is 625/37 times G. Can I have the RB value? How much? 500/37G. Is that okay? Okay, that's not what we need, however. We are supposed to find the value of our theta. So obviously to find the theta value, what should you do? You must take now the last thing remaining. We did horizontal, we did vertical. The final thing that's remaining for us to proceed is what? To do? To consider moments. So let's consider moments around which point? You can consider moments around either A or B. You could go with either one. Okay, so yeah, which one? B. It doesn't matter which one you go with. Okay, so then you can go with either moments around A or moments around B. So so there's a suggestion. Let's do moments around B. Okay, so it doesn't matter either way. So if I take moments around B, I'll consider clockwise as positive. What are the forces we have? At B, the FB and the normal reaction B are both not gonna produce moment because they both go through B. Shall we try 25G? What kind of a moment do you think 25G will produce? 25G gives you a, it gives you a anti-clockwise, right? Yeah, it's pulling this way. It's anti-clockwise moment, so I use clockwise as positive. So minus 25G. What's the perpendicular distance? Now you can see your force is horizontal, right? If your force is horizontal, the perpendicular distance is, sorry, if your force is vertical, now our force is vertical here. If our force is vertical, the perpendicular distance from point B to the force is horizontal. That's the catch here. When your force is vertical, the perpendicular distance between the point that you are taking the moment and the force is going to be horizontal. So basically, what's the horizontal force? From B, directly draw a horizontal line. Do you see the horizontal distance now? How much is it? This is 1.5, and you can see the theta comes over here on top as well, right? The theta comes on top as well. Do you agree with me? This angle is theta again. So I can resolve the horizontal distance is going to be what? This horizontal distance is going to be 1.5 sine theta or cos theta. 1.5 cos theta. I'm taking the horizontal distance. It's towards the angle. 1.5 cos theta is the distance. Are you clear with that? So that's the part that many of you are having problems with. So 25G into 1.5 cos theta, because I resolved and got this distance. This is towards the angle. Okay, let's try the next one. Normal reaction A is giving you a what kind of moment? So it's pulling upwards. Around B, when you pull upwards, you are giving a clockwise moment or anti-clockwise moment around B. It's a clockwise moment. Do you see? It's a clockwise moment. This is the way it's pulling. So plus normal reaction B into, sorry, normal reaction A, right? Normal reaction A into what's the distance? So again, it's a what force? This is a vertical force, which means perpendicular distance must be what? From B, the perpendicular distance is horizontal. So this yellow color distance I marked is the horizontal distance. Can I know how much this distance is? How much is the distance? The whole AB length is 3 meters. So 3 cos theta, right? This distance 3 cos theta. Okay, I'm removing all the extra things here. So the normal reaction A into 3 cos theta. Okay, and then this is equal to, sorry, not equal, there's more, right? Who else do we need to consider moments about? Friction A, right? Friction at A. So friction at A is a force that's horizontal, pulling like this. So around B, it's giving a clockwise moment or anti-clockwise moment, this guy. It pulls this way. Around B, it's giving a anti-clockwise moment. Do you see the way it pulls around B? It's an anti-clockwise moment. So therefore, I'll give negative. Friction B into what's the perpendicular distance? Now you know here, friction A, sorry, this is friction A. So what's the perpendicular distance? So you know the force A is, sorry, friction A, friction at point A. It's a force that goes like this. The force is originally horizontal. So what's the distance, the perpendicular distance between B and this particular force? It must be a what force? It must be what distance? Now your force is originally horizontal, which means your perpendicular distance must be, vertical. Okay. So your perpendicular distance is going to be this particular distance. Are you with me? The yellow color distance I marked. This is the vertical distance. How much is it? This is 3 towards the angle. This is away from the angle. 3 sine theta. You see the vertical distance is 3 sine theta. And this whole thing equals to 0. The whole thing equals to 0. Do you agree with me? Because it's in equilibrium. Everything must add up to 0. Shall we simplify? So now it's a matter of simplifying. Minus 25G into 1.5 cos. Can you multiply 25 and 1.5? I'm not going to multiply in the G. Leave the G. 25 times 1.5 is how much? 30 minus 37.5 G cos theta. I multiplied only the 25 and the 1.5. Okay. Normal reaction A was how much? We found it, right? Normal reaction A is 625 over 37 into G. 625 over 37 G into 3 cos theta. minus friction A. Friction A is 4/5 times normal reaction A. 4/5 times normal reaction A is how much? Normal reaction A was found 625/37 G, right? Are you with me? So here FA is the friction A is 4/5 into RA. RA is 625/37G into 3 sine theta. Are you following me? Are you following me? This is the friction A value. This entire value here is the friction A value. This okay? Is this clear? Okay, so we need to now make what? Tan theta, right? And everyone I think has a G. Do you see? Shall I simplify a little bit here? Minus 37.5 G cos theta. 625/37 into 3 is how much? 625/37 into 3 without giving the G value. How much is it? How much? 625 times 3/37. 1037 G cos theta. Multiply minus 4/5 into 625/37 into 3. There's another 3 also. 4 minus 4/5 into 625/37 into 3. Minus 1500/37 G sine theta. This is just multiplying all the numbers in the cal, okay? And then the whole equation we could divide by what? To create the tan. We can divide the whole equation by cos theta. Divide the whole equation by cos theta. Then minus 37.5 G, cos to cos will cancel. Plus 1875/37 G, cos to cos will cancel. Minus 1500/37 G. Sine divided by cos gives you tan. Do you follow what I just did here? I divided the entire equation by cos theta. That gives me the cos and the cos terms, the cos will cancel when you divide by cos. But the sine, when you divide by cos, you get a tan. And each and every single term here has a G, which means I can remove the G. Or else, in other words, you could say you divide the whole equation by G. And that's gone. Then what's remaining here? Minus 37.5 plus 1875/37. I can take the minus 1500 to the other side as plus 1500/37 times tan theta. I think they want the exact answer, right? Can I have the figure here? Minus 37.5 plus 1875/37. Type this in the cal. What do we get? Minus 37.5 plus 1875/37. How much do we get? 975/74. 1500/37 tan theta, making tan the subject. So tan theta is 975/74 into 37/1500. How much is it then? They want the exact value of tan theta, not the theta value, but the fraction. So type this in the cal. 975/74 into 37/1500. How much do we get? 13/40. So that's it. Find the exact value of tan theta. This is the exact value of tan theta. Okay? This is it. Okay, moving on to question number 4. The uniform lamina L shown shaded in figure 2 is found by removing the square PQRV of side 2A and the square RSTU of side 4A from a uniform square lamina ABCD of side 8A. The lines QRU and VRS are straight. The side AD is parallel to PV and the side AB is parallel to PQ. Okay, and the side AD is parallel to PV and the side AB is parallel to PQ. The distance between AD and PV, the distance between AD and PV is A. Okay, so it's marked here. And the distance between AB and PQ is also A. Okay, so you can see in the diagram how they have marked. The center of mass of L is at the point G. Okay, so the center of mass of the whole thing is at the point G. Show the distance of G from the side AD. So from the side AD, let's say the center of mass is somewhere over here. I'm just roughly marking. So if this is the center of mass, then they are asking the center of mass distance from AD. Basically, the distance from AD means what coordinate? The center of mass distance from AD means it's the x bar, right? They want you to find the x coordinate. Are you with me? Okay, so to do this, what we do is just take one point as 0, 0 first. I'll consider D as 0, 0. Shall we mark all the coordinates with respect to that? So here A will be 0, 8A because the whole length is 8A. This will be 8A, 0. Do you see? Because the length is 8A, so XY coordinate. This will be 8A, 8A. So I'm going to draw a small table here with object, mass, and the center of mass. The first object I'll be considering is the large square ABCD. So mass is proportional to the area, right? Are you aware of that? Mass is proportional to the area in a lamina. So 8A into 8A. How much is the mass? 64A square. Okay, and the center of mass of this big square is exactly in the middle, right? So it's exactly in the middle means what? It's 4A, 4A. I'll write both x and y coordinates at the same time. You'll fill it, so it's easy for us. And the next one. The next one, we will consider the small square that we are removing, PQRV. So what is the mass of PQRV? Length into breadth, 2A into 2A, right? Which is how much? 2A into 2A is 4A square. And what about the center of mass? I want the distance from the from point D. So from point D, what's the x distance? I mean, you can see here. This is already A, and this the center of mass point is exactly in the middle of the square. The square length is 2A, which means this length should also be how much? Should also be A, right? So it's going to be how much? 2A. And the y coordinate is this distance. How do I find that distance? So basically, this is A. Again, you need to realize since this is 2A here, this short distance is again A. Are you following me? This is the distance I wrote in black here. This is A because the whole length is 2A. Half of it is A, which means from the top border, from the AB line, the center of mass of the small square is at a distance 2A. So if it's at a distance 2A, that means from the bottom, it's at a distance 8A minus 2A, 6A. Are you following me on what I'm saying? Do you follow me on what I'm saying? The distance from here to here is 6A. Is that clear? Then do the same thing now for the next square. RSTU. So it's 4A by 4A. So what's the mass? 4A into 4A is 16A square. And then the center of mass coordinate, can you all tell me how much of a distance we have? This distance is already how much? 1A plus this 2A. Altogether this is 3A. Do you agree? And this distance is half of 4A, which is 2A. So altogether my x distance from the center of mass of the big square is 5A. Do you agree with me? The y distance, how do I find this y distance? So to get the y distance, what I'll do is I'll get the distance from the top. So from the top, the distance from here to here is, this distance is 1A plus 2A. This is 3A. And again, half to the middle, the center of mass, the half of 4A is 2A. Basically, this whole distance is 5A, which means the distance to where I want from 8A, when you subtract 5A, it's 3A. Do you agree with me? Okay, and then, so these are the two squares that we remove. So these are the two squares that I'm removing. So what am I ending up with? So in the ending shape, we remove these two squares. Can I know the mass of the resulting object? The mass of the resulting object, we subtract the 4A square and 16A square from the 64A square. How much is it? How much is it? 64 minus 4 minus 16 is? How much? 44A square. Is that okay? And then the center of mass is x bar, y bar. This x bar, y bar is measured from the point D. That means from AD and DC. Okay? Okay, I want the distance from AD. So let's get the x bar. Let's use moments. Okay, basically there's a question here. Basically, can't we use 0, 0 as the point A? You can. There is absolutely no problem in using a different point as 0, 0. You could use any one of the points as 0, 0, anyone that's convenient to you. Okay, so here I chose to use D as 0, 0, but if you prefer to use A as 0, 0, then that's perfectly fine. You can go ahead with it. Okay, okay, let's find the x bar. 64a square times 4a plus 4a square times 2a. Sorry, it's not plus, right? Why? From 64a square into 4a, from the big square, we are removing these two squares, right? So removing means I must subtract minus 4a square into 2a. We are taking the moment, mass into center of mass coordinate must be multiplied. Minus 16a square into 5a. Right? So from the big square, subtract these two. This is equal to total mass is 44a square into x bar. Are you with me? So shall we simplify? Can you all get me the answer here? I think a square is common to everyone. I'll cut off the a square. Can you all get me the answer? 64 times 4 minus 4 times 2 minus 16 times 5. How much is it? 64 times 4 minus 4 into 2 minus 16 into 5. How much? 168a equal 44 times x bar, which means x bar is 168a over 44. Can't we simplify this a little bit first? How much? 42 over 11a. And this is your x bar. Is this a show that? Yes. So we got the show that. Do you see? So we get the show that. Okay, so then we'll move to the next part. They say the mass of L is M. Okay, so they have given you the mass. Okay, let me erase all these things now. So the mass acts at the center of mass, right? So the mass at the point G, the mass of L is M. We are supposed to use capital M as a mass, and a particle of mass Km is attached to L at C. Okay, at this point we are attaching another particle of mass Km. The lamina with the attached particle is freely suspended from B. Okay, so they are suspending the particle from B and hangs in equilibrium with BC, making an angle 45 degrees with the horizontal. Find the value of K. The first thing you need to realize here is now at the point G, we have the mass capital M. At the point C, we have the mass Km, right? Okay, so then basically when you now the center of mass of this figure was at this point G. But when you attach this extra figure, do you think the center of mass of the entire compound figure is going to be over here now? No, it will move to a new position, right? It will move to a new position. So first what I do here is I can get the new, I want to find the position of the new center of mass. Okay, what I'll do here is this. Okay, so first of all, what we'll do here is we will calculate. I got the before attaching km, we got the center of mass x coordinate, right? Okay, we found the center of mass x coordinate. Can you also find the center of mass of the y coordinate? What's the center of mass y coordinate? Quickly. Get the, wait, let me check. Okay, we'll not go for the y bar. Wait, what we'll do here is now I was asking you previously, let's get the y bar value here, right? Okay, there's no need, I think, because it's only 4 marks. What you do here is this. Now we already know the x bar distance, right? From the center of mass, we know this x bar distance. Am I correct? What is the x bar distance? 42 over 11a, right? 42 over 11a. Okay, I know the x bar distance. What we'll do is, shall we find the position of the new center of mass? Okay, because you know when you attach this particle Km, the center of mass will obviously move, right? So for part B, I make another table, object mass, center of mass. And the first object is this. Okay, so what was the mass? They have told the mass is supposed to be, now we are not going to use areas now because mass is given to us in terms of M. So mass is capital M. Center of mass x coordinate was found as 42 over 11a. Do you agree? I'm not using the y coordinate. Let's just go with the x coordinate for now. And then what's the next object that I'm attaching now? I'm attaching this tiny particle, right? At C. So the mass of that object is km. So center of mass in a particle, we will have to just go with the coordinate of the particle. Okay, for the center of mass, we will just have to go with the coordinate. So what was the coordinate? We measured the center of mass, the 0, 0 was at D. So with respect to D, what's the x coordinate of km? 8a 0. I will only use the x coordinate because I only have the x coordinate here. Okay. And then the combined object. So in the combined object, what happens? You have m plus km is the total mass and the center of mass is what I'm trying to find now, the new x bar. Shall we find the new x bar? Find the new x bar. M times 42 over 11a. Are we adding or subtracting km times 8a? Adding. Equals m plus km times x bar. M times 42a over 11 plus 8kma. Taking m out, 1 plus k times x bar. M is common. Remove m. Can you all add this over here? 42a over 11 plus 8. Actually, we will have to take the common denominator here, right? Okay. Let's make the common denominator here. 11 will multiply both up and down with 11. 42a plus 88ka over 11 times 1 plus k equals to x bar. Is that okay? So this is the x bar coordinate that I'm getting. Now the thing is, what they're saying here is, now look at what they're saying here. Now they're saying here, the lamina with the attached particle is freely suspended from B. Now, you know, when you attach these two particles together, you get a new center of mass, right? So let's say this is the G dash new, the new center of mass. So they say here, when the particle hangs in equilibrium with B, the BC makes an angle of 45 with the horizontal. Okay, now what's the theory when you hang? What's the theory when you hang? I'll remove the previous center of mass. Okay, because of the Km particle, you now have a brand new center of mass. Okay. Okay, because of the when you hang the Km mass, you have a brand new center of mass. So what happens now? The rule of hanging is the place where you hang, and the center of mass of the object becomes the vertical, isn't it? This is called what? This is the downward vertical. Are you with me? This is the downward vertical. So basically, they say here this downward vertical makes an angle of how much? 45 degree with the horizontal, not the vertical. Okay, so anyway, if it's 45 degree with the horizontal, what do you think is the angle it makes with the vertical? If it's 45 with horizontal, what's the angle it makes with vertical? Because horizontal and vertical have a relationship, it's a 90 degree, right? So if it's 45 with horizontal, then the angle with vertical also is 90 minus 45, right? So then 90 minus 45 with vertical. So if they said here, the angle with the horizontal is 60, I would have used 30 with the vertical. Got it? So the angle between the vertical and the downward, the BC and the downward vertical is 45. This is 45. Do you agree with me? So if it's a 45 degree, here it's a 90 degree, you need to realize this is also going to be, the other side angle is also going to be 45, right? Because when you have a 45 degree and 90, the other angle is automatically 45. Do you agree with me? So which means what? So which means that these two distances, okay. Okay, so 45 means I have a what? I have a isosceles triangle over here. Do you agree with me? Yeah, and this 45, actually you can make this diagram more accurate. Okay, the downward vertical, they say it's making an angle 45 degree with vertical. Since you have a square, and you know in a square all of these angles are 90, 45 degree with the vertical means what? How do you think the downward vertical should go? I'll erase everything. It must go through the diagonal. It must go through the diagonal because the diagonal of a square is bisecting the 90-degree. So basically, this is the how it should go. Okay, so it goes through this, and your point G has to be somewhere in the middle. The point G has to be somewhere in the middle. Are you with me? Then the new center of mass has to lie on this particular line. Because they say that it makes an angle of 45 degrees with the vertical. With the horizontal means 45 with horizontal means 45 with vertical. So 45 with the vertical means this BC makes an angle of 45 with the downward vertical means this is already a square. And since the at each point, at each angle, we have a 90 degree, the 45 degrees should go through like this. Do you agree with me? Okay, so now how do we proceed from this point? Now look at this. There are certain theories you need to remember here actually. Okay, the first thing is if I erase all of these again, okay, if we consider back to our original diagram, okay, now the thing is if you consider back to our original diagram back in part A, do you see that this particular shape, you know, in center of mass, if a certain object has a line of symmetry, the center of mass is definitely lying where? On top of that line of symmetry, right? Now, if you look at the shape, the original shape, do we have a line of symmetry here? Who is the line of symmetry? Can we take the midpoint of AB and DC or the midpoint of AD and BC or the BD diagonal? Who is the line of symmetry here? Do you see that there is a line of symmetry, first of all? Who is the line of symmetry? Do you see that the AC diagonal is a line of symmetry for this particular shape? AC diagonal is a line of symmetry. Do you agree with me? So if there's a line of symmetry, what does it indirectly mean? It means your center of mass definitely lies on this line of symmetry. Are you agreeing with me? Do you agree with what I say? So this is my line of symmetry. Okay, this is my line of symmetry, which means the part A answer I found. Now they told me the answer, the distance G from the side AD is 42 over 11A, right? So do you think this 42 over 11A could be like anywhere randomly over here? No, it must be on this line of symmetry. Okay, because if there's a line of symmetry, center of mass of the object must be on the line of symmetry. Which means this the distance, this particular person G, I'll just mark G somewhere over here. It could be over here, but we have removed a larger mass from here. There's a smaller mass removed, which means there's more weight distribution to this corner. I'll put this as G. Okay, so this is the point G. Are you with me? So this is where the mass is acting. Okay, are you okay with me? So this is the distance that we used as 42 over 11A. Are you okay with that? 42 over 11A definitely lies on this axis of symmetry. Now, they say in part B that they're hanging another object called Km at C, right? They're hanging another particle called Km at C. Now look at this. Now, when you attach this Km, you know, definitely you're adding another mass. So the center of mass, will it now lie at this point? No, it will definitely move. When you attach another object, the center of mass, now the previous object didn't have the Km. The center of mass was here. Now, when you attach the Km, what happens? There's an additional mass and thereby the center of mass will move. But now, do you see that Km, adding Km, does it affect our line of symmetry? Does it make any change? Is the object still symmetrical or not? With the Km also is attached on the line of symmetry, right? Which means the shape is still symmetrical. So when this object is attached here, the new center of mass, what happens? The center of mass will slightly move towards the Km because there is a weight here. Are you getting what I'm saying? The center, when you attach another weight and since it's on the line of symmetry, the total mass, now you know the total mass is where the center of mass acts, right? So the total mass is going to be m plus km and that also should definitely lie on this AC line. It should also definitely lie on the AC line. Do you agree with what I say? Because this is also on the line of symmetry. So this is the new center of mass, the new G. Okay, and then they say here an additional thing. Now you pinpointed that the new center of mass is on the line of on the line AC. It's on AC, on the line of symmetry. And then they say that that when you hang this from B, Okay, when you hang it from B, the side BC makes an angle of 45 with the horizontal. Or in other words, the side BC makes an angle 45 degree with the vertical. When you hang it from B, are you with me? So when you hang it from B, 45 degree with the vertical means you realize it goes like this, right? So this is 45 degree to the vertical. When you hang it from the point B, 45 degree to the vertical is this, which means what? Which means now you know this is the downward vertical. The downward vertical, what's the rule of the downward vertical? It always passes through the center of mass, right? Which means your center of mass, can it be somewhere randomly over here? Now your center of mass is directly over here. This M plus Km. The new G bar is over here. Do you agree with me? So which means the new G bar, the new center of mass is at the place where the two diagonals intersect. The new center of mass is at the place where the two diagonals intersect. Do you agree? Because the downward vertical also, the rule of drawing the downward vertical is you draw it from the point where you hang, and it must definitely pass through the center of mass. The center of mass, since it and since your center of mass makes an angle 45, it has to be going through the diagonal of your square because it's 45 degrees. It has to go through the diagonal, which means your center of mass, the new G bar has to come over here. Do you agree with me? Okay, so which means what? Now I think you already found the new center of mass, right? The X bar new value as this. So this new X bar value, do you think that we know the real value of it? Yes, we know this distance. How much is it? It's exactly in the place where the two diagonals intersect. It's exactly the middle of your square. What's the exact middle of your square? The X coordinate is 4a, half of 8a, right? Distance. So basically you can say here, the new X bar is 4a. It's all a matter of understanding here. 42a plus 88ka over 11 times 1 plus k equals 4a. So I can remove a is common to everyone. So I get here 42 plus 88k. 4 times 11 is 44 times 1 plus k. Are you with me? 42 plus 88k. 44 into 1 is 44 plus 44 into k is 44k. And then let's move the 44k to the other side. 88k minus 44k equals 44 minus 42. 88 minus 44 is how much? 44k, right? Is equal to 2 here, which means k equals 2 over 44. 2 over 44, in other words, is how much? 1 over 22. So there's quite a lot of thinking to do here. If you think of all these strategies correctly from the beginning, you can get the answer quite easily. But you need to realize that your center of mass is going to be at the intersection point of the two diagonals. Okay, so that's the thinking part you have to understand in this particular sum. Okay. Okay, question number 5. At time t seconds, where t is greater than or equal to 0, a particle p has velocity v meters per second, where v equals 3t square minus 9t plus 6i plus t square plus v minus 6j. Find the acceleration of p when t equals 3. Okay, how do we find the acceleration? You must first differentiate the given, to find the acceleration from velocity, you have to differentiate. So when you differentiate, 3t square differentiation is 6t. Minus 90 differentiation is minus 9 plus 6 is 0, right? So basically you differentiate the I component and the j component. So the I component differentiation was 60 minus 9. The j component differentiation is t square differentiation is 2t plus t differentiation is 1 minus 6 is 0. So that's it. This is j. So basically when I differentiate, sorry, this is not v, this is the acceleration. Are you with me? I got the dv by dt. Basically this is the dv by dt. Differentiating v with respect to dv by dt, or the acceleration is 60 minus 9i plus 2t plus 1j, and then we need to replace t with 3. So when t is 3, 6 times 3 minus 9i plus 2 times 3 plus 1j. 6 times 3 is 18. 18 minus 9 is 9i. 2 times 3 is 6 plus 1, 7j. So 9i plus 7j meters per second square. So they ask you to find the acceleration, not the magnitude. Okay. So we can leave it at this point. Okay. Okay, are you okay with it? So you just need to find the acceleration as a vector. They don't ask you for the magnitude, so you don't need to go there. Part B, they say when t equals 0, p is at the fixed point O. The particle comes to instantaneous rest at the point A. Find the distance OA. So basically, they have given you the starting point here at time 0, p is at the fixed point O. Basically, it's at the origin. So at time 0, you are at the origin. They ask you the particle comes to instantaneous rest means the velocity is when you come to instantaneous rest, the velocity becomes 0, right? It comes to instantaneous rest at the point A. Find the distance OA. First, shall we find the time when it comes to instantaneous rest? So V equal 3t square minus 9t plus 6i plus t square plus t minus 6j. Okay. So what do we do here now? So when you come to instantaneous rest, your velocity becomes 0. So basically 0i, 0j. And you get something like this, right? T square plus t minus 6j. So take each icon. Now the I component also must be equated to 0 and the j component also must be equated to 0. Is this the method that you all did? So you make the I component equal to 0. Can I know the answer we get here? Dividing everyone by 3, t square minus 3t plus 2. What are the two t values here? So I get here t equals to what? T equals 1. However, this is not finalized. Why? I have to also get the t value that agrees that becomes 0 for j also. Because it comes to rest means the I component and the j component must both be 0 at the same time. Then I need to get the j component equal to 0. What are the two factors here? T minus 2t plus 3, which means I get t equals to 2 or t equals to minus 3. So what's the correct t value that corresponds to both I and j becoming 0? T equals to 2. So t equals 2 is the place where you come to instantaneous rest. So that's the point A. T equal 2 is your answer. Okay. So now using t equals 2, we have to find the distance. We have to find the distance OA. Okay. How do I get distance from velocity? We must integrate. So let's integrate. So let's integrate velocity. When you integrate 3t square integration gives me 3t cube over 3 minus 9t square over 2 plus 6t. This is I. Plus t cube over 3 plus t square over 2 minus 6t times j. And then don't forget the plus c. Okay, so velocity integral gives us the displacement, the position vector basically. The velocity, because it's with ij, you get r here. Okay, we write r because it's a position vector you get. Then we get here t cube minus 9 over 2t square plus 6t times I plus t cube over 3 plus t square over 2 minus 60 times j plus c. How do we find the plus c here? They have told here at time 0 that it's at the fixed point O, which means at time 0 you are at the origin. So at time 0, the R value is 0y 0j. Are you with me? Let's substitute 0y 0j. And when you replace t with 0 here, this is all becoming 0y. When you replace t with 0 here, everything becomes 0j plus c. Basically, your c is 0, which means the position vector is r equals t cube minus 9 over 2 t square plus 60 times I plus t cube over 3 plus t square over 2 minus 60 times j. So replace the t value with what? We found it comes instantaneous rest. The point A is when time equals 2. Replace t with 2. Replace t with 2. How much is it? How much is the ij value? Two y minus 22 over 3j. They want the distance OA, so you need to get it the square root of it. So modulus of this 2 square plus minus 22 over 3 square square root. How much is it? How much is it? 2 root 130 over 3 to 3 SF. Write the 3 SF answer as well. Do they want? Find the distance OA. Let's give the 3 SF answer as well. 7.60 meters. Okay, so this is the answer. Are you okay with it? Is this clear? Okay, question number 6. A rough straight ramp is fixed to horizontal ground. The ramp has length 15 meters and is inclined at an angle alpha to the ground where tan alpha equals to 5 over 12. The line AB is a line of greater slope of the ramp where A is at the bottom of the ramp and B is at the top. Okay. A particle P of mass 6 kg is projected up the ramp with speed 40 meters per second from A in a straight line towards B. Okay, so they are projecting a particle from A towards B. The coefficient of friction between P and the ramp is 0.25. Find the work done against friction as P moves from A to B. Okay, so when the particle moves from A to B, what's the work done against the friction? So basically your particle is moving up, right? So when your particle is moving up, the friction is acting downwards. So what is the work done against friction? So what do we normally consider as the work done against friction? Work done against friction is the friction force multiplied with the distance it moves, right? You multiply the force into distance. Force, you multiply with the respective distance that the object moves along the line of direction of that force. So here the friction force, now you can see here they have given you the coefficient of friction. The object is moving, which means obviously you have the maximum friction. That means your friction is the mu r friction. And your distance is what? Your distance is the AB distance, which is how much? Which is 15. Okay, mu value is given to you as 0.25. Can I know how much is the normal reaction here? So your normal reaction is like this, right? This is normal reaction. What are the other forces here? You have the weight, so you have the mass 6g. And from the mass, you can get the components of the mass, right? So you have here what? So you have over here what? This is 6g cos alpha. And the other side we have 6g sin alpha. Are you with me? So basically R is equal to what? I think you can very clearly see R is equal to 6g cos alpha because these are the two forces acting perpendicular to the plane. Okay, R is equal to 6g cos alpha. So R is 6g cos alpha multiplied by 15. So can you all tell me what's the cos alpha value? Tan alpha value is given to you as 5 over 12. So when you mark the diagram here, alpha, cos, tan alpha is to opposite over adjacent, isn't it? Opposite over adjacent. So in the right angle triangle, I can get the other side by using Pythagoras theorem. 5 square plus 12 square, square root of that, that should give you this. What is this? 13. 5 square plus 12 square, square root gives 13. So let's input the value now. 0.25 into 6 into G is 9.8. Okay. Into cos alpha is how much? Cos alpha adjacent over hypotenuse is 12 over 13 into 15. Can I know the answer here? How much is the answer? You should get a decimal answer. You get a fraction answer. But the thing is, we have used G as 9.8. The instructions in the M2 paper very clearly say to you at the front page of the M2 paper, it says whenever you use G as 9.8, you must keep your answer to 3SF or 2SF. Okay, so how much is it? 204 to correct it to 3SF. Okay, because you do get a big answer, you can make it a fraction as well, but you should not keep your answer in exact form here. By any chance, you shouldn't keep it in exact form because you have used G as 9.8. That's really important. That's the instruction that they give to you. Okay, so you have to follow the instructions to the letter. Okay, then the work done against friction as P moves from A to B is 204 joules. So work done. So it should be measured in joules. Okay, it's energy. Okay, then the next one, at the instant P reaches to B, the speed of P is V. Okay, so you reach at this point, the particle comes here and it doesn't come here, just it has a certain speed, right? It reaches here with a speed V. Then they say after leaving the ramp at D, the particle P moves freely under gravity until it hits the horizontal ground at the point C. Now, after leaving the ramp, how do you think this object will go? It will just fall directly to the ground? Now, you know, you're projecting this particle with a speed. It comes up over here, right? The particle, we hit it. We okay, so now the particle, you know, it initially launches from here, and we give it quite a bit of a velocity, right? They say the particle is projected up the ramp with a speed of 40. So it comes to this point, and they say here very clearly that it comes here with a certain speed. We don't know the speed, but it comes here with a certain speed, and then with that speed, it's going to jump out of this ramp. So when it jumps out, you need to realize what's going to happen here. What's going to happen here? Is it just going to fall directly down, just like this? Is it just going to fall down like this? No, it has a speed here. Thereby, it will start to move as what? It starts to move like a projectile. This is basically a projectile. So basically, you have your projectile path like this. Do you see what's going on here? Okay, you can try to draw a projectile path. Okay, sorry. Okay, so you draw a projectile path. Okay, so then, okay, so the angle that the projectile path makes is the same angle theta here because we projected along with this angle, sorry, alpha. The angle is alpha over here. Okay, so they're asking you in part A. Now they say here, after leaving the ramp at B, so that is this projectile path, the particle P moves freely under gravity until it hits the horizontal ground at the point C. So do you see the point C? I marked it where it hits the ground. Immediately before hitting the ground, the speed of P is W. So immediately before hitting the ground, the speed is W. Okay, use the work energy principle to find the value of V. Okay, how do I find the value of V? To find the value of V, I have to consider the energy at A and energy at D, right? Okay, so let's consider the ground level is the potential energy 0 level. For part B, Roman number 1, when we use energy, what do we use here now? Obviously, in for the movement from A to B, is energy conserved? No, when you are moving from A to B, you are moving under the frictional force. So there is some, you lose the part of your energy, which means we had to use the work energy principle here. So the work energy principle means we say the work done against friction is equal to what? Work done against friction is equal to the change in energy. Is equal to the change in energy. So work done against friction was found as 204 joules. Change in energy. So initial energy is the larger one. The initial energy, you have to subtract from the final energy. You do realize your final energy is lower than the initial, right? Because whatever you start here, because when you travel through the rough ramp, you lose part of your energy. Thereby, initial is larger. So what are the energies we have initially? At the initial point, you start here with a speed of 14, right? Which means you have kinetic energy. So you have kinetic energy, initial KE. You have initial KE. And then minus, what about when you come to over to this point? What's the final energy you have here? You have GPE, right? You have GPE. Okay, and then is that all the energy you have at point B? No, you also have what? You also have the final kinetic energy, isn't it? You have at the initial point, we only had KE because we were at the ground level, potential energy is 0. But at this point, you have a GP, you're above the ground, and then you also have a final kinetic energy. Okay, so let's input the values now. The 204 equals the values here. Okay, so shall we use the value here? For the work done against friction, shall we use the full figure? The 0.25 into 6G cos alpha times 15. Okay, so what I used here is I use this value over here. Okay, now here the thing is for 204, it's a rounded off figure, right? So instead of using the rounded off figure, we will use the full value here and then we'll get our answer. Okay, shall we? So initial kinetic energy is half, m is 6, mass is 6 kilogram into velocity is 14, right? Initially they said that the particle starts at A with a speed 14, half mv square minus the at the point B you have the potential energy mgh, but height here means you have to take the vertical height. So what's the vertical height over here? So you'll have to resolve, right? 15 cos alpha, it's 15 sin alpha. Do you agree? H is the vertical height at this point. At the point B, the vertical height is 15. Towards the angle is a cos. Away from the angle, vertical is sine. So 15 sine alpha. M is 6G. 6G H is 15 sine alpha. Plus kinetic energy is half m v square. So this is what I'm trying to find, right? I'm trying to find the energy, the the velocity at this point, half mv square. Okay, so shall we input the value now and try to find the answer? 0.25 is 1 over 4 into 6g. Cos alpha is 12 over 13 into 15. Can you all simplify? Simplify, make V the subject. Simplify here, I get 3 times 14 square. So this one becomes minus 6g into 15. Sine alpha is so opposite over hypotenuse, right? So opposite over hypotenuse, 5 over 13. Again, opening the bracket with the negative sign. Be careful with the negative sign you are opening. So it's minus half into 6 is minus 3v square. Are you with me? Minus 3v square, I bring here as plus 3v square. I get here 3 into 14 square minus 6g into 15 into 5 over 13. This whole thing comes to the other side as a minus 1 over 4 into 6g into 12 over 13 into 15. Okay, so then this is what I have. So type this full figure in your cal and divide it by 3. And we have to take the square root of this answer as well, right? So let's type it off. Okay, so in the next part, you can see I have typed the whole thing in the calculator. 3 into 14 square minus 6g is 9.8 into 15 into 5 over 13 minus 1 over 4 into 6 into 9.8 into 12 over 13 into 15. I type the whole thing in the cal. I get 588 over 13. This is 3v square, so we divide by 3. And I get v square is 196 over 13. So v is the root of that. So take the square root of your answer. Square root of the answer. And we get 14 root 13 over 13. But don't leave this as an answer. You must keep it to a maximum of 3 significant figures. Why? Because we have used G as 9.8. So maximum 3 SF. So 3.88. It is absolutely important that you leave your answer to 3SF here. Okay, because you use G as 9.8. Okay, are you okay with that? Okay, so then we move to the next part. They say you to use the work energy principle to find the value of W. So again, I must tell you that when they say to use the work energy principle, it means you must use work energy. You cannot use SUVAT equations or F equal MA or do anything like that. Okay, because you can see it's a projectile here and you might feel compelled to work with the projectile equations, right? So do not go with that technique. They ask you very clearly to use the work energy principle. So when you're traveling from B to C, what we all, if you want, you could go from either A to C direct, or we could go from B to C. Okay, so I'll go from, we could go either way. Okay, so if we go from B to C, we already found the value of our V, right? We already have the V value here. So if we go from B to C, we can again apply the conservation of energy rule, the work energy principle. Basically from B to C, the object is freely moving under gravity. So we don't have any non-gravitational resistive forces here. Energy is conserved. Basically, whatever the energy you have at in Roman number 2, the energy you have at B is equal to the energy you have at C. And energy is a scalar quantity, which means does it matter about the direction? At C, at B, you have the velocity in this direction. At C, it's in a completely different direction. But energy is scalar, thereby it does not matter. The directions do not matter. So I get here energy at B is half, M is 6, half mv square. So v square is the value that I found just now, half mv square. Is that all the energy that I have at B? No, right? It's above the ground, which means we also have mgh. Mgh is 15 sine alpha. Do you agree with me? This is the energy we have at B. Energy at C we have when you hit the ground. You have the potential, kinetic energy, half mv square. The energy, the velocity is W, half m W square. And do we have any GPE? When you hit the ground, there's no GPE, right? You're on the ground level. Okay, so then basically input the value here. Half into 6 is 3. V square value once we already have. V square is 196 over 13. Let's use that value. Plus 6, G is 9.8 into 15. Sine alpha is how much? What was our sine alpha? From this opposite over hypotenuse, 5 over 13. Half into 6 is 3 times W square. Are you with me? Okay, so then can you all simplify? Type the whole thing in the cal and divide the answer by 3. Three times 196 over 13 plus 6 times 9.8 into 15 times 5 over 13. This is okay? I get something like this and then divide by 3. So that is W square. So W square and then square root of the answer to get W. So 11.3 to go 3SF. Definitely give you answer to 3SF because we have used G as 9.8 here. So 11.3 meters per second. This is clear? Question number 7. Particle A of mass 3m is moving in a straight line with speed 2u on a smooth horizontal surface. Particle A collides directly with particle B of mass m, which is moving along the same straight line in the same direction as A. Did you see that? So both the particles are moving what? Both particles are moving in the same direction. Are you with me? Particle A of mass 3m is moving in a straight line with speed 2u. Particle A collides directly with particle B of mass m, which is moving in the same straight line and in the same direction. So basically, it's the same direction. Okay, so the direction of particle B, particle B is also the same. Okay, particle A collides directly with particle B. So AB, particle A collides directly with particle B of mass m, which is moving along the same straight line in the same direction as A. Immediately before the collision, the speed of B is u. Okay, so the speed is u. That is before the collision. So you can see immediately why this is colliding, right? This A is having a higher speed than B. Okay, so they say as a result of the collision, the direction of motion of B is unchanged. Okay, basically A comes and hits on B, and then after that, the direction of motion of B is unchanged. And the kinetic energy gained by B is 48 over 25 mu square. Find the coefficient of restitution between A and B, and you can see they've given you how many marks for this? They have given you 8 marks. Okay, so shall we write the speeds after the collision as xy? Now the thing is, we are definitely sure about one direction here. Who is that? I'm definitely sure of the direction of B, right? Because when A comes and, when it collides with B, B is already moving to the right. And when you come and hit the object which is already moving to the right, you push it to move faster, right? That's why they say the kinetic energy gained by B. Do you notice they say the word kinetic energy gain? Because the particle B, when A comes and collides with particle B, it gives a support to the direction it's already moving. Thereby, it will definitely what? Increase in its velocity in the same direction. So particle A might have option, it can turn back or it can continue to move forward. Okay. Right. So I will use it in this manner and we'll see what goes on. So then they say as, okay, so what we'll do here is first we will use the law of conservation of what? The law of conservation of momentum. So by the law of conservation of momentum, what happens? Initial momentum equals final momentum. Initial momentum is 3m times 2u plus m times u equals final momentum is 3m into x plus m into y. So everyone is to the positive direction, to the right. So no issues there. I can cut off the m here. What do we get here then? 3 times 2u is 6u plus u equals 3x plus y. Are you with me? So 7u equals 3x plus y. Do you agree with me? Shall we also, they have given us one more thing about the kinetic energy gain. Let's write about the KE gain. So kinetic energy gain in B, right? They have said here the kinetic energy gained by B. Kinetic energy gained by B is, how do we find the gain? Kinetic energy gain means what? Gain means it has increased. So basically the amount that has increased. So what is the increment in the kinetic energy? To find the increment in the kinetic energy, you have what? Subtract what from what? Initial from final or final from initial? Final from initial, because your final K is greater. Definitely you realize the Y velocity is higher than U because it comes and supports the direction that B is already moving. So final KE minus initial KE. So kinetic energy gained is 48 over 25 mu square. Final kinetic energy is half my square. Okay, mass is m. Okay, so use m here. Initial kinetic energy is half mu square. Okay, kinetic energy is a scalar equation. So basically, the direction of the energies don't actually matter. Okay, m is common to everyone. Cut off the m value. Simplify. 48 over 25 u square minus half u square comes as plus half u square equals half y square. What happens? 48 over 25 plus half gives us how much? 48 over 25 plus half. How much? 121 over 50 u square equals half y square. So input the y value, y square value here, 121 over 50 u square into 2 equals y square. So 21 over 50 times, when you times it with 2, we get 121 over 25 u square equals y. Do you agree with me? So when you y square, so when you root it, square root of 121 over 25, root of 121 is 11, root of 25 is 5, u square root is u. And we don't need to put plus or minus here because we are definitely sure y is positive. The direction that I have used is definitely what? It is definitely correct because we definitely realize y is going to the right side. So then using the y value, you can now input that and find the x value. So replace the y value. 7u equals 3x plus y. Replace. How much was our y value? The y velocity is 11 over 5u. So make x subject 7u minus 11 over 5u equals 3x. So 7 minus 11 over 5 is 24 over 5u equals 3x. Thereby x is, you can see we get a positive figure here, right? That means the direction I have used for x is correct because I'm getting a positive figure. 24u over 3 times 5 is 15. Do you agree with me? 24 over 15 can be simplified, right? 8 over 5. 8 over 5u is equal to x. Do you agree with me? So I have the initial velocities and now the final velocities. So now I can use the restitution. I had to find the restitution. So E equals to speed of separation over speed of approach. Speed of separation is we can go x minus y. Over approach, you have to exchange and put u minus 2u. Do you remember? Separation, speed of separation over speed of approach. If you use x minus y, then the other one, you have to exchange and write u minus 2u. And then use the directions and see whether anyone needs to change. If there's anyone who needs to change the direction, then we need to consider changing the sign here, the plus minus. So here everyone is to the same side. All of them are to the right side. So I don't need to consider change the direction of anyone. So we'll find the E value of x was 24u over 15. Sorry, 8 over 5u, right? Minus y was 11 over 5u. Divide by u minus 2u. Can you all simplify? 8 over 5 minus 11 over 5 is 8 over 5 minus 11 over 5 is minus 3 over 5u. Divide by u minus 2u is minus u. So minus divided by minus is a plus. The u and u cancels. You get 3 over 5. So basically the E value is 3 over 5. This is okay with you all. I have written this all over the place, but this is the final part. Okay, this is the final answer that I took the xy values and I used the restitution equation up over here. Okay, so this is the answer for 8 marks. Moving on to the next part. After the collision, B hits a smooth fixed vertical wall that is perpendicular to the direction of motion of B. Okay, so particle B hits a smooth vertical wall, right? So it hits a smooth vertical wall. After the collision, B hits a smooth vertical wall, and we know the speed that is going to hit the wall, right? It hits with the speed y. Okay, given that immediately the speed of B after first hitting the wall is equal to the speed of A. Okay, so it's equal to the speed of A now. Okay, so given that the speed of B immediately after hitting the wall is equal to the speed of A immediately after its first collision with B, find the value of F. So when this goes and when it rebounds back, they say the rebounding speed is equal to the speed of A after the collision. So what's the speed of A after the collision? We found it, right? X value was 8 over 5u. This is the speed of A just after the collision. So they say after B goes and collides with the wall, it rebounds back with the speed that A has after the collision. So then taking this into consideration, they are asking you to find the coefficient of restitution F. So when you hit a wall or a ground or a solid surface, we use the coefficient of restitution is V over U, right? We don't need to use speed of separation over approach or everything is already done. We can directly use this equation V over U when you hit a solid when you hit a wall or if you hit a ground. In that case, we use this equation. So V is the speed of rebounding, which is 8 over 5U. You don't have to consider directions here. Directions have already been considered in building this equation. And U is the speed of hitting the wall. What's the speed of hitting? Y value was 11 over 5U, right? This Y value is 11 over 5U. So this is the speed with which you hit the wall. Can you all simplify this? 8 over 5U divided by 11 over 5. U to U will cancel. 8 over 5 divided by 11 over 5. You can I can see the answer, but in an event you don't. Okay, you can type like this 8 over 5. But it should be pretty obvious to you that the 5 will cancel out. Okay, you can type like this in the calculator. 8 over 5 divided by 11 over 5. The 5 to 5 cancels. It's 8 over 11. So this is the coefficient of restitution between B and the wall. And you can see it's just 2 marks. So you need to do only working relevant for 2 marks. Is this clear? Okay, so now we'll move on to question number 8. They say in this question, the unit vectors I and j are in a vertical plane with I being horizontal and j being vertically upward. At time 0, a small ball is projected from a fixed point O on a horizontal ground. The ball is projected from O with velocity pi plus qj meters per second. Okay, where p and q are positive constants. The ball moves freely under gravity. At t equals 3 seconds, the ball passes through the point A with velocity 8 pi minus 12j meters per second as shown in figure 4. Find the speed of the ball at the instant it is projected from O. They are asking you to find the speed at the beginning when it's projected. Okay, so how do we get the speed of projection? Okay, so what do we know about these components? Now they have marked the initial components here, right? So Pi plus Qj means you do realize your horizontal component is Q. And your your horizontal component is Pi, Qj. So your vertical component of velocity is Q. And over here, do you see 8i minus 12j is also the velocity, right? So 8i is the horizontal component. So 8 meters per second horizontal component. Minus 12 means what? Your y component is directed downwards. So you don't have to mark it down and don't mark minus 12, just mark 12. The minus is there to tell you that the component is downward. And then when it comes to projectiles, there's a very important rule. What's the most important rule when it comes to these kinds of projectiles? The horizontal component is the same throughout the motion. Anywhere in the motion, anywhere throughout this motion, the horizontal component will never change. What's the horizontal component? So I think we have the component value over here, which is 8. So throughout the entire motion, the horizontal component at every single point is 8, which means we have the value of what? Which means we have the value of what? P. So directly P is equal to 8. So nothing to, you don't have any working there. Directly you say P equals 8. Okay, how do I get Q? So Q is a vertical component. Of course, vertical component is the one that will change, right? Vertical component, as you move up, it will get, it will decrease in value, isn't it? Vertical component decreases in value at the top, at the highest point, vertical component becomes 0. Okay, and then over here, now the vertical component is downwards at 12. So what equation do I have to use to get the value of Q? We will use, we can use V equals U plus 80 and we can apply it vertically upwards, or you can apply vertical downwards, direction of your choice. Okay, so V equal U plus 80. Are you with me? So V is the final velocity. I'm applying this in the vertical direction. Okay, only the vertical components are considered. So V, what's the final component of velocity? So I'm considering from O to A. O to A. The motion from O to A. Okay, so what's the final velocity? It's 12. It's 12 downwards. Therefore, since I apply upwards as positive, it's minus 12. U, initial velocity, initial vertical component of velocity is Q. Q upwards, therefore it's positive. And then plus acceleration. You know, this is an object moving freely under gravity, so acceleration is going to be negative G because it's directed downwards. I'm using the equation upwards. Into, what about the time? They have given us that time 3 seconds. Okay. So we have everything we need. All we need to do now is make Q the subject. So when you make Q the subject, I get here minus 12 plus G into 3, which is 3G. So how much is the Q value? Minus 12 plus 3G. When you type in the cal, minus 12 plus 3 times, minus 12 plus 3 times 9.8, right? Minus 12 plus 3G. So can you see the answer we get? We get 17.4. Okay, I get Q is 17.4. So there's no, we don't have to, we don't need to round it. It's already in 3SF. Okay, so normally whenever you use the value of G in a calculation, you must, whenever you use G as 9.8, you use the value of G as 9.8, you must give the answer to 3SF or 2SF. Okay. Then in part B, find interval of t seconds, the speed v of the ball is such that v is less than or equal to 10. Now they used, sorry, I'm not done with part A, right? In part A, they asked us to find the speed of the ball. So what's the speed? So speed is the, I have the two components, horizontal and vertical. So to get the speed, we have to take the sum of the squares and square root or get the magnitude. So p square plus q square square, which is 8 square plus 17.4 square root, and give the answer definitely to what? Since you have used G as 9.8, definitely give the answer to 3SF here. So what did we get? 8 square plus 17.4 square root of your answer, and we get 19.150. So we get this big answer. So either 2SF or 3SF. Okay. So I'll go to 3SF, 19.2. Or you could leave your answer as 19 meters per second is also okay. Okay. Part B, they tell you find interval of capital T seconds, the speed V meters per second of the ball is such that V is less than or equal to 10. Okay, what component are we talking here? We are talking about the speed. So you know, speed is the resulting, right? There is the resultant. So basically here, now here when I got the speed as 19.2, that's the resultant of the Q and P, isn't it? 19.2. So likewise, you realize that when you are moving up, is your speed increasing or decreasing? The speed is decreasing because you are moving up against gravity. Your speed decreases, and there comes a point in your path where what? Where the speed actually comes to a point where it comes to where the speed comes to 10. The resultant. Okay. So they say here, so then so you come to the point where the speed is 10, and when you move above this point, what happens? The speed is even less than 10, right? Because you realize that at the more up you go, the speed is decreasing. And then you come to the other side and you realize the other side is completely symmetric, isn't it? Okay. So they are asking us to find the interval of values such that V is less than or equal to 10. Okay, so how do we do this? Yeah, so I'll mark 10 a little bit higher than this. I've marked it in line with this, which is, so we'll mark it a little bit higher. Because, so if you calculate the speed at this point, 8 square plus 12 square root, you get a speed which is 14.4, which is higher than 10, right? So you need to realize what I'm doing here is I'm finding so this is the interval because your speed is your speed decreases and it comes to a point where the speed becomes 10. So above that point, definitely your speed is less than 10. And then after you pass the maximum, okay, you are repeating the exact same speeds again. Okay, so okay, so we have to find this is the interval of this is the length, the space where the object is traveling, and the speed is definitely less than 10. Are you with me? So it's during this this period. Okay, so you're supposed to find the value of t, the time taken to move through this interval. Okay, is this clear? I hope you realize that this speed over here, so this is again 10 over in the other side. Okay. This is 10 here, symmetrically exactly on the other side. If you go horizontally across, you come to the other point where the speed is 10 again. Okay. So we need to find the speed over at this point. How do we find the speed? How do we find the time? So to find the time, what we can do here is I realize that still the horizontal component is still the same, right? The horizontal component will not change, which is what? Which is 8. So it's the vertical component that I need to find because the vertical component is what gives the difference in the speeds, right? Okay, so with this, what can we do now? What's the next step that we need to go ahead? Okay, so one way of getting this component is we could say this component is, so we'll say this is y, the y component. So you can find the y component by doing y square plus 8 square. So if you square and root it, you get 10, isn't it? So when you take the squares, take the sum of the squares and you root it, you get the magnitude, you get the speed. Okay, when you take the magnitude of velocity, it's the speed because it's 8i plus yj. So I get here removing the root, I'll square both sides and I'm going to get y square plus 8 square equals 10 square, which is 100. So then I get y square equals 100 minus 8 square, which is 64. How much is y square? 100 minus 64 is 36, which gives me y equals root 36, which is 6. You need to realize here, so at this point, I know this is definitely a positive y, positive 6, okay? So I'll be working with positive 6 because the direction is upwards. Okay, are you with me? So this is 6. So to get the time, so now I have the vertical component, which is the crucial element. So now how do I get the time? There are two ways of getting it. You can apply V equal U plus AT. So let's say this is point X and this is point Y. You could apply V equal U plus AT directly from X to Y. Because you need to realize that if the component will these two components change when you go to the other side? It's the exact same components. However, what the direction, the 8 is exactly the same. The 10 is now not upwards, but the 6. The 6 is not upwards, but now the 6 is downwards. The exact same thing. Okay, so you could apply V equal U plus AD from X to Y and directly get the time. Or another person could apply V equal U plus AD from here to the highest point. At the highest point, the vertical component of velocity becomes 0. So you could apply V equal U plus AD from here to the highest point, get that time and multiply it by 2. Because this time is equal to the time on the other side. Okay, so both of those methods are correct. V equal U plus AD from X to the highest point, calculate the time, multiply it by 2 and you get the full time. Or you apply V equal U plus AD for the whole, for the entire X to Y motion. And then you directly get the time. Okay. So here I'll use part B. I'll use V equal U plus AT X to Y. So I will directly use. So choose a positive direction. That's really important. Choose a positive direction. So I'll choose upwards as positive. So if I choose upwards as positive, who is B? So B is the place where I end up, starting at X, ending at Y. So if I'm ending at Y, I'm using this vertical components, right? So you can see 6 is downwards while I'm using upwards. So this V is minus 6. Initial velocity, you start at X, which is upwards, you get plus 6. Plus, what about the acceleration? Moving freely under gravity is the 9.8. It's the G value, but it's going to be negative G because I'm applying the equation upward. Time taken is capital T, which is what I want to find. So I'll move the minus GT to the other side to make it positive GT, and I'll move the minus 6 here. Minus GT moves here as plus GT. Here I get 6. The minus 6 comes as plus 6. So GT equals 6 plus 6 is 12. T equals 12 divided by G. Are you with me? So you can see you're going to directly use the value of G now. 12 divided by G. 9.8. Okay, in mechanics, G is 9.8, and you can see 60 over 49, which is 1.2244. So you can see this big answer. So when you use G as 9.8, again, you must keep your answers to 3 significant figures or 2 significant figures. I'll keep it to 3, 1.22 or even 1.2 is correct. So your answer T equals 1.22 seconds. Is this clear? This is the answer for part B. Okay. Then we'll move to the part C. In part C, they say at the point B on the path of the ball, the direction of motion of the ball is perpendicular to the direction of motion of the ball at A. Okay, where is the motion at A? Okay, this point. So they say at the point B on the path, the direction of motion of the ball is perpendicular to the direction of the motion of the ball at A. Find the vertical height of B above A. Okay. Okay. So what do we do here? First thing is you need to identify where this point B is, right? Okay. How do we identify where B is? Okay, so how do we find the position of B? Okay, to find the position of B, they say now at the point B on the path, okay, at the point B on the path, the direction of motion. So direction is what you get through the speed. The direction of motion of the ball is perpendicular to the direction of the motion of the ball at A. So the motion of the ball at A, I think you can see it's like this, right? This is the direction of the motion of the ball at A. Can you see? I just made the line longer. So then you have to find a point in this path where if you take the direction, that direction should be perpendicular to the direction of it. Okay, so you don't need all these elaborate diagrams. It's just a small thing to do, but I'll just draw it and show you. So place where you make a 90 degree. Okay, so somewhere like here, let's say this point. So this is the height of B. Sorry. Okay, so I'm having a hard time to draw it, but basically, let me just draw it. So if you take this point B, so there's a point B on the path. So there, when you consider the speed, it will be right angles. So it will be right angles to the direction. The at the point B, the speed is at right angle. The direction is at right angles to the direction of A. Okay, so we don't need to need all these things. We just need to use a simple theory here. What's a simple theory here? Okay, at the point B, at any point, your horizontal component of velocity is 8. Okay, it's the vertical component. That's the issue here. So we have to get the vertical component. So how do we get the vertical component? Okay. So you can't say A and B are completely aligned. We can't use things like that. So the thing here is to get the vertical component. How do we get the vertical component? So one simple theory when we say this motion of the directions are perpendicular. So now the direction of A and B are perpendicular, right? So for example, if I say, if I mark the angle between the resultant direction of the at the point B and say I'm marking the direction with the horizontal component. So let's say I'm marking this angle as theta. So if I take this angle as theta, then this angle theta will be on at the point A. It will be with the vertical. So this is the theory that it comes when you are working with perpendicular direction. Okay, so why this is happening? I think I have explained this earlier also. Okay. So I have drawn the full diagram here. It's not necessary to draw these things, okay? But just because you have questions how it comes, so I extended the lines here to complete the right angle triangle. So this theta comes here because it's corresponding angles. And then since it's a 90 here and this is theta, 90 and theta, the other side angle should be 90 minus theta. This 90 minus theta comes over here as alternate angles. 90 minus theta. Thereby, this angle at A will become theta. Okay, so you don't need to draw through all these diagrams. All you need to remember is that the component. Okay, the angle between if you take the angle between the resultant and the horizontal component at one point, that same angle will be repeated between the resultant and the vertical at the other point when the directions are perpendicular. So that's it. Okay, so all we have to do is to get the value of theta and I just need to find the vertical component of velocity at B. That's what I need to do here. Okay, so how do I get the vertical component of velocity? Okay, so first thing is how do we get the theta value? Yeah, how do I get this theta value? So we'll use tan theta here because we know both the values 8 and 12, right? So we can use tan theta here. Tan theta is opposite over adjacent. So use tan theta at both these places. Are you with me? So tan theta in the first one over here, we may have the angle with the horizontal component. So opposite is the vertical, adjacent is the horizontal. So opposite component, let's say it's V1 or V. So opposite is V over adjacent is 8. Are you with me? Tan theta for this one is V over 8. On the other side, if you take tan theta over here, who is the opposite now? For this theta, is it the 12 or is it the 8 who is the opposite? It's the 8 who is the opposite. So 8 over the adjacent is 12. The opposite is the 8. The opposite side is the 8. Adjacent is the 12. Okay. So now can't we easily find the vertical component? V equals 8 times 8 over 12. You get V equals how much? 64 over 12, which is 16 over 3. So that's the vertical component of velocity. This is what I mainly need. So now with this vertical component of velocity, what are we supposed to do? They want you to find the vertical height of B above A. Okay, so you need to find the vertical height of B above this point A. So how do I get the vertical height of B above A? We use V square equals U square plus 2AS from B to A. So choose a positive direction. So I will apply downwards because they ask you to find the height of B above A, which means B is above, so A is below. So I chose downwards as positive, okay? How much is final speed? Final vertical component of velocity is 12, isn't it? So I'm using downwards as positive, therefore positive 12. Positive 12 square initially The one we start at B. So with what's the vertical component at B? We just found it 16/3 and it's upward. I am using the equation downward. Thereby it's minus 16/3 square. Plus 2 into acceleration due to gravity, that's positive 9.8 and h. So this is the height difference. This is the height difference, the displacement. Okay, so since A is below B, that's the reason I use downwards as positive, because from B to A, your displacement is h, a positive h downwards. Okay, the shortest distance, shortest vertical distance. Shall we get the value of h? So I get here 12 square minus 16/3 square equals 2 into 9.8 into h. How much is 12 square minus 16/3 square? 12 square minus 16/3 square. I get 1040/9. So this should be divided by 2 into 9.8, right? Which gives me, so definitely give you answer to what? 3 significant figures, which is 5.895. So when you correct to 3SF, it's 5.90 or 5.9. Are you with me? H equals 5.90 meters. So maximum 3SF, or you can leave your answer even to 2 significant figures. Is this clear? Okay, so this is the end of this mechanics paper.